All right, let's dive into the universal theory of communication. It's the framework that underpins our entire digital world.
The big question is, how can a fragile message survive a noisy world? Well, this theory explains it.
First things first, we got to separate three ideas we always confuse: information, signal, and of course, meaning. So, information, that's just uncertainty. A signal is how it travels, and meaning, well, that's on us.
And here's the genius part. The theory ignores meaning entirely. That's what makes it so universal, from DNA to data.
So the real enemy isn't failure, it's noise. The theory doesn't aim for perfection, but for something way more powerful. It's called asymptotic reliability. Basically, you can make the chance of an error get ridiculously small, close to zero. Information is all about reducing uncertainty. And to do that, you first have to measure it. Entropy. Think of entropy as surprise. Something totally predictable, zero surprise, zero entropy. Pure randomness, maximum surprise.
This leads to source coding, compression. It works by just stripping out all the predictable, redundant parts.
But then, channel coding does the opposite. It adds smart redundancy back in to protect against noise. So here's the kicker. Redundancy isn't waste, it's protection. But even with perfect protection, there's a speed limit. And this limit, called channel capacity, isn't about our tech. No, it's a hard rule from physics itself. And get this, if you double your power, you do not double your speed. It's totally counterintuitive. That's because the limit is logarithmic. You get diminishing returns. So we have to think about it differently, as geometry. Okay, picture this. Your messages are points in space, and noise, it draws a little bubble of uncertainty around each one. To avoid mistakes, you just have to keep those bubbles from touching. That's it. That's the limit. Now, this same geometric idea scales up to whole networks. But there's a huge blind spot to this entire theory. So, the theory can send anything perfectly, but does it understand any of it? The answer is a hard no. It sends Shakespeare's sonnets and total gibberish with the exact same perfect precision. It can't tell the difference.
And that's the big paradox, right? Our global network works because the theory has no idea what it's carrying.
See, the sender encodes the message, but only the receiver can give it meaning. The channel itself is totally blind.
So, can a theory that is blind to meaning really be enough for our future? That's the big question we're left with.